So let's talk about the conceptual model, and I'll go through the notation here, but how to think and what to do with the conceptual model we'll cover in the lecture instead. So notation-wise, a conceptual model is just like a class diagram. Hang on, let's click there. So, like this. I'm using, by the way, I'm using star UML. You can use whichever UML tool you like, or for this particular exercise, when you do conceptual model, you could probably do it with a normal drawing program as well. So now I have a concept. That's as easy as it is. Let's say I want to do an attribute on this, like this. Yeah. So now I have a concept with an attribute. Just the simple notation for this. And then associations, like that. Give it a nice name. Yeah. Like that. So just a line between different concepts and we have an association. There is one thing which may make this slightly more complicated, and that is that we can have multiplicity. So we can say that on this side, for example, so now this concept has 0 or 1 of another concept. We can have, as you can see, you can have exactly 1. We can have 0 or more, 1 or more, or an arbitrary number. We can also put a range between 5 and 10, like that. Or we can put precise numbers like 6 or 20. I don't know why you would have 6 or 20, but that's possible at least. On this association, we can also have a name that sort of describes the relationship between these two concepts. Now, there isn't very much room in this conceptual model to actually provide information for exactly what this concept is about. So you would also have a document next to it where you do a dictionary. So concept and a brief explanation, 1 or 2 sentences, what the concept is and what attribute is in relation to this concept. So let's delete this for a while. Let's do a better example. Let's do the point of sale system again. So we have point of sale. We have what do we have? We have a cashier. Let's model the cashier. We don't know what's going to be a concept yet, so let's do that. In that case, we have a customer. These obviously are going to, cashier and customer are obviously going to become actors and not concepts, but for now let's put them in. You can always remove them later. We have something called a sale. We have a sale item. I think sorry. What else do we have? We have a receipt. We have an inventory. So let's move this one, move that one, and let's remove this one. So those would be our concepts. We can say that a point of a sale is related to a sale item. An inventory. Oh yes, we have of course items as well. Let's add those. Or those are the things that we have in the store, I presume. The inventory maintains a list. We can be rather verbal here. Maintains a list of is okay. This receipt is associated to the sale. Let's keep that unnamed for now. And that's basically how you do your conceptual model. You just model the different concepts you have. At the moment, you see we don't have any attributes. Let's add, for example, in a sale item, there might be a price. On a sale, we can have a total. Receipt might have a date. Possibly a time as well. And so on and so forth. Now, what is an attribute and what is a concept? Let's discuss that during lecture. And how to find these concepts and how to think about them is also something we're going to discuss during a lecture. Going from this, as you can see, I'm using the class diagram notation for this. So the difference between a conceptual model and a class diagram is not in how we model it. It's more in terms of how we think. You'll notice, for example, that I don't have any iterators or collections or anything like that here. I've just got domain entities, things that I can find in the domain, and the relationships that are in the domain. So I'm not thinking about implementation details. At the moment, I don't have any methods on this. We'll come to them later. But the idea is in UML is that you start with something that is using the same notation, and you try to reuse that same notation for as many things as possible, so that what you do when you go into the next iteration is that you add more details, and eventually you have a class model that you can even generate code out from. And go back to classes like that. I have one class and I have another class. So if I want to, I can have different types of associations here. I can have this regular association. I haven't really specified exactly what type of association it is. I can have an aggregation. So class 1 consists in some sense of class 3, and I can have a composition, which means that in class 1, class 3, in that relationship, class 1 is responsible for dealing with class 3, and it creates it and everything. In the class 4 instances here, because it's a filled-in diamond here, class 1 cannot exist without having class 4 there. We can also have inheritance. Should be here. Yeah, good. So class 5 inherits from class 1. Those are also things, you can use them in the conceptual view as well, especially the inheritance thing might be relevant there, but most of the time it isn't. In the conceptual view, you would stick with regular associations. The composition and inheritance are more of an implementation detail. So let's have a new class over here. Attributes, as we saw, is simple. I had an attribute like that. Another attribute. Let's put a name on this. Let's call it address and a type. Like that. So now I have one attribute named attribute1, creative, and I have another one called address of the type string. They're both publicly visible. So let's double click on that one and see I can make them protected, or I can make them private. So address, let's make that one private. You see that's a minus sign then, meaning that only member functions of class 6 can see the address. Let's add a method to this, like this, a public operation. Add a method that returns something. Let's be safe. Like this. So we have the method getAddress that returns a string, a constant string to be safe.